Hello, I'm Ken Schweeder. I'm a Global Product Manager in Emerging Chemical Synthesis here at Merck or MilliporeSigma in the US and Canada. For today's virtual seminar, I'm going to discuss our offering in Photoredox catalysis. Before we jump into the topic at hand, first want to give an overview of innovation that we're focusing on to accelerate drug discovery. So we have offerings in the lead discovery area, such as our off-the-shelf DNA encoded library, as well as in chemical biology with our protein degraders. We have a reaction design. We have our retrosynthetic software, Cynthia. Then today we're going to focus on the areas of small molecule synthesis and reaction platforms with the area of photoredox catalysis. So this short seminar will be broken down into three parts. The first we'll discuss the photocatalysts themselves. We have worked with many players in the field to develop a robust offering over the years. We will then move on to talk about our photoreactors, which we pride ourselves in having plug-and-play reactors that have been designed to bring consistency and reproducibility to any photocatalytic reaction. And the last piece, arguably the most important, is the know-how content that we provide to beginners as well as experts. So jumping into the photocatalysts, and we have photocatalysts ranging from all different types. The classical iridium and ruthenium catalysts are strongly represented. We have over 50 combined of those two types. We then have some of the newer organocatalytic, or the organophotocatalysts, including some acridinium catalysts brought in from the Nishevitz lab, as well as some beryllium phenoxazine catalysts brought in from Garrett Miyake's group, as well as some joiner acceptor catalysts. And as I mentioned, we source a lot of our innovation and work with, and through many collaborations, different professors throughout the world. So if you are interested in commercializing a photocatalyst, please don't hesitate to contact me. My contact information is shown on this slide. Moving on from the photocatalyst to the photoreactors, we have three different main reactors that all focus on different aspects of reaction design and optimization. So the first is our photocatalysis reactor focused on reaction screening. We then have the Synlet Parallel photoreactor for reaction optimization. And lastly, the workhorse instrument is the Penn-PhD photoreactor M2. And an important thing to remember is that all of these reactors have been designed to bring consistency and reproducibility. So going into further detail with our screening reactor, it's the photocatalysis reactor. So as you can see here, we have the starter kit contains an LED controller allowing you to adjust the intensity of the light, and also comes with a 470 nanometer LED array. So it's a blue light source, and then the reaction block and screwdriver. The consumable part of this platform is our 24 catalyst plate. And so this is a general screening kit. You have a wide range of photocatalysts included. So some acridiniums, iridium, ruthenium, as well as a few other different types of catalysts. And each kit contains 2 plates and 4 different solvents for screening. The main features here, this is a microscale format. So the user is able to run 24 unique reactions using approximately 100 milligrams of their own substrate. As we mentioned, this has 24 pre-weighed catalysts. It's 0.1 millimole of each. And the LED controller allows for variable intensity. And there are 3 different LED arrays available, the 470 nanometer blue LED that comes with the starter kit. And then there's an add-on 527 nanometer green LED, as well as a white LED array. Moving on to our next photoreactor, we have the Synlet Parallel photoreactor. This is a great reactor for reaction optimization as well as small library synthesis. So this features a 4x4 array of 16 1 to 2 dram vials, and then each slot is one bottom lit LED. So these are blue LEDs with a wavelength range from 465 to 470. And then this reactor also has a built-in cooling fan to provide consistent temperature, approximately 30 degrees C, and this fits well onto a round ICA stir plate. The big selling point of this reactor is that it has a consistent temperature and light intensity to all 16 vials, allowing for, as I mentioned before, reaction optimization as well as library synthesis. Moving on to our third photoreactor, we have the PEM-PHT photoreactor. And this is our workhorse instrument. The scale ranges from GC vials all the way up to 40 mil vials. The modular design allows for a variety of wavelengths. So the instrument comes with a 450 nanometer light module, but a 365 nanometer and 420 nanometer light modules are also available. The 360 degree reflective environment is able to maximize photon capture. Other interesting aspects of this are the touchscreen allowing easy user interface, as well as the different parameters that the user is able to define. That includes temperature, intensity, fan speed, and stirring. And another interesting aspect of this is that coming later this year, our multi-vial holders. So the current version allows only one reaction at a time to be run, but the additional vial holders will allow up to 5 reactions to be run at one time in the photoreactor. And moving on to our last piece here, we have a number of resources available on our website. So the first and most powerful is our user guide. This is a approximately 50-page user guide written by experts in the field that focuses not only on reaction setup, but also on different theory, as well as many different types of reactions that can be run. The next is our Photoredox Catalysis Hub here. So if you're interested to look at our full product offering or access any of this content we've talked about today, you can find that at sigmaaldridge.com/photocatalysis. And lastly is our technical spotlight, which goes over some of the background of photocatalysis as well as detailed descriptions of our photoreactors, including a table that describes the differences between the 3 different photoreactors. Thank you for your time.